All right, hello everyone. Let's try this again. Now, this is a different look for me because my other computer is not um, getting the book that I need to be reading. And so I'm trying to improvise here. But welcome to my channel. And this is an educational channel. We focus on shedding light on subjects that are important to me, but maybe you haven't heard of them. And so maybe they'll be important to you if you learn about them. Today is the 162nd video that I've done on the reciprocal system of theory. This is a theory that was originally devised by Dewey B. Larson back in the 20th century. He died back in 1990, and since then, some other people have done some work on the theory and advanced it some more. But basically, it is a system of theory, meaning that if you understand how the system works, you can plug it in yourself to whatever subject you'd like. Not only that, but you no longer have to rely upon the pointy-headed scientists with the lab coats to tell you what you're supposed to think about all of this stuff. You can figure it out for yourself. But it does take a lot of work. And so that's why I'm going through several of his books and many other articles and so on to kind of get you up to speed on the theory if you are dedicated enough to watch the videos and stuff. Now, the basic idea behind Larson's reciprocal system is that we live in a universe of motion. The universe is made out of motion, not matter, not energy, but motion. Matter and energy are merely two different kinds of motion, along with pretty much all of the other scientific entities that you know of: acceleration and force and gravity and matter and magnetic flux and electric charge and electric current and pressure. These are all different forms of motion. And other people have come up with the concept of the universe of motion before, but Larson took it into another level by identifying motion as the relationship between space and time. That sets up a reciprocal relationship between space and time, and hence the name, the reciprocal system of theory. And basically, space and time, motion is a fraction with time or space as the numerator and space or time as the denominator. Space or time both have their coordinate aspects, meaning that they both have 3 or more dimensions. They both also have their clock aspects, meaning that they both progress. Time is always getting later and later and later. Space is always getting farther and farther and farther apart. They both also come in only discrete units. There is no, there's a minimum unit of space and a minimum unit of time. Those units are very small, so it looks continuous, but it is not. It comes in chunks and discrete units. And 1 unit of space in 1 unit of time is the speed of light. So the speed of light is the one. Larson calls it unit speed, and that the unit speed is what Einstein said that the speed of light is the maximum speed of the universe. But in Larson's system, the speed of light is the midpoint of the universe. So half the universe is moving faster than the speed of light, and half is moving slower than the speed of light. Larson calls these the cosmic sector and the material sector, respectively. And that the speed of light is what he calls the progression of the natural reference system. So most systems, their reference system is comes from 0. You measure from 0. But in Larson's system, we measure from the speed of light. Is it faster or slower than the speed of light? If it's slower, then it's a material sector thing, and you have space over time relationships. If it's faster, it's a cosmic sector type of thing, and you have time over space relationships. Now, the cosmic sector is something that we don't know much about. Einstein knew nothing about it. He said that the speed of light was the maximum speed of the universe, neglecting the entire cosmic sector, where in the speed of light is actually the minimum speed of the universe. And but through the power of the reciprocal system, we can understand what's going on in the cosmic sector, because it is merely the reciprocal of what's going on in the material sector. So if we understand things about the material sector, all we have to do is invert or reverse the roles of space and time, and then we get exactly what's going on in the cosmic sector. Now, today, that's just a brief overview, but today we're looking at his 1979 book that is called Nothing But Motion. And this is the first of a 3-volume work that's called The Structure of the Physical Universe. It covers primarily physics. First volume, this volume, is primarily physics with a little organic chemistry. And then the second volume, Basic Properties of Matter, is on chemistry. And then the third volume, Universe of Motion, is primarily on astronomy, maybe entirely on astronomy. We'll look at those other books later, but right now we're in chapter 8 of this book, and chapter 8 is called Motion in Time. So this more or less refers to this faster than the speed of light motion. And so we will let Larson speak in his own words, starting from here. When the progression within a unit of motion reaches the end of the unit, it either reverses or does not reverse. There is no intermediate possibility. It follows that what appears to be a continuous unidirectional motion at speed 1/n is, in fact, an intermittent motion in which space progresses at the normal rate of 1 unit of space per 1 unit of time for a fraction, 1/n, of the total number of space units involved, and has a net resultant of 0 in the context of the fixed reference system during the remainder of the motion. Now, this may not be the best place to get started here. You might want to go back and refer to my previous videos where I read the paragraphs before this, the whole book before this, really. I think this is like the 33rd video that I've done on this book so far. If the speed is 1/n, 1 unit of space per n units of time, space progresses only 1 unit instead of the n units it would progress unidirectionally. The result of motion at the 1/n speed is therefore to cause a change of spatial position relative to the location that would have been reached at the normal rate of progression. Motion at less than unit speed, then, is motion in space. This is a well-known fact, but because of the uncritical acceptance of Einstein's dictum that speeds in excess of that of light are impossible, and a failure to recognize the reciprocal relation between space and time, it has not heretofore been realized that the inverse of this kind of motion is also a physical reality. Where the speed is n/1, there is a reversal of the time component that results in a change of position in time relative to that which would take place at the normal rate of time progression, the elapsed time registered on a clock. Motions at speeds greater than unity is therefore motion in time. So motion in time is faster than the speed of light. Motion in space is slower. The existence of motion in time is one of the most significant consequences of the status of the physical universe as a universe of motion. Conventional physical science, which recognizes only motion in space, has been able to deal reasonably well with those phenomena that involve spatial motion only. But it has not been able to clarify the physical fundamentals, a task for which an understanding of the role of time is essential. And it is encountering a growing number of problems as observation and experiment are extended into the areas where motion in time is an important factor. Furthermore, the number and scope of these problems has been greatly increased by the use of zero speed rather than unit speed as the reference datum for measurement purposes. While motion at speeds of 1 over n, speeds less than unity, is motion in space only when viewed relative to the natural or the moving reference system. It is motion in both space and time relative to the conventional systems that utilize the zero datum or the zero reference point. It should be understood that the motions we are now discussing are independent motions, physical phenomena, not the fictitious motion introduced by the use of a stationary reference system. The term progression is here being utilized merely to emphasize the continuing nature of these motions and their space and time aspects. During the 1 unit of motion, at the normal unit of speed that occurs periodically when the average speed is 1 over n, the spatial component of this motion, which is an inherent property of the motion independent of the progression of time that is likewise independent of the progression of the reference system, the time aspect of which is measured by a clock. Thus, during every unit of clock time, the independent motion at speed 1 over n involves a change of position in 3-dimensional time, amounting to 1 over n units. As brought out in the preliminary discussion of this subject in Chapter 6, the value of n at speeds of our ordinary experience is so large that the quantity 1 over n is negligible, and the clock time can be taken as equivalent to the total time involved in motion. At higher speeds, however, the value of 1 over n becomes significant, and the total time involved in motion at these high speeds includes this additional component. It is this heretofore unrecognized time component that is responsible for the discrepancies that present-day science tries to handle by means of fudge factors. And when Larson says fudge factors, he basically is just meaning things that are thrown in there to make the numbers and the equations balance out, but they are not science. They are, it's a fudge. It's something that you're using to make it look like everything is okay. An example that Larson cites a lot for that is constants. If you put in a bunch of constants into your equations, then it still makes it look like you know what you're doing, but you're actually fudging the equation. Okay, back to Larson. In the 2-photon case considered in Chapter 7, the value of 1 over n is 1 over 1 for both photons. A unit of the motion of photon x involves 1 unit of space and 1 unit of time. The time involved in this unit of motion can be measured by means of the registration on a clock, which is merely the temporal equivalent of a yardstick. And that's interesting because Larson never really stated this right out, but in general, at least in this sector, in the material sector, a yardstick is straight and a clock moves circularly. In the same way, space is straight and time is curved. Now, in the cosmic sector, it would be the reverse. But just kind of keep that in mind. Time is measured in angle. Okay, in the material sector. The same clock can also be used to measure the time magnitude involved in the motion of photon y. But this use of the same temporal yardstick does not mean that the time interval through which y moves is the same interval through which x moves. The interval, he calls it OX, any more than using the same yardstick to measure the space traversed by y would make it the same space that is traversed by x. The truth is that at the end of 1 unit of the time involved in the progression of the natural reference system, also measured by a clock, x and y are separated by 2 units of total time, as well as by 2 units of distance, or 2 units of space. The relative speed is the increase in spatial separation, 2 units, divided by the increase in temporal separation, 2 units, or 2 over 2 equals 1. If an object with a lower speed v is substituted for one of the photons so that the separation in space at the end of 1 unit of clock time is 1 plus v instead of 2, the separation in time is also 1 plus v, and the relative speed is 1 plus v over 1 plus v equals 1. Any process that measures the true speed rather than the space traversed during a given interval of standard clock time thus arrives at unity for the speed of light irrespective of the reference system, which is what was determined by the Michelson-Morley experiment of 1887 or so. When the correct time magnitudes are introduced into the equation of motion, there is no longer any need for fudge factors. The measured coordinate differences and the measured constant speed of light are then fully compatible, and there is no need to deprive the spatial coordinates of their metrical meaning. Unfortunately, however, no means of measuring total time, except in certain special applications, are available at present. Perhaps some feasible method of measurement may be developed in the future, but in the meantime, it will be necessary to continue on the present basis of applying a correction to the clock registration in those areas where this is feasible. Under these circumstances, we can consider that we are using correction factors instead of fudge factors. There is no longer an unexplained discrepancy that needs to be fudged out of existence. What we now find is that our calculations involve a time component that we are unable to measure in lieu of the measurements that we are unable to make. We find it possible in certain special cases to apply correction factors that compensate for the difference between the clock time and the total time. A full explanation of the derivation of these correction factors, the Lorentz equations, is available in the scientific literature and will not be repeated here. This conforms with a general policy that will be followed throughout this work. As explained in Chapter 1, most existing physical theories have been constructed by building up from empirical foundations. The reciprocal system of theory is constructed in the opposite manner. While the empirically based theories start with the observed details and work toward the general principles, the reciprocal system starts with a set of general postulates and works toward the details. At some point, each of the branches of the theoretical development will meet the corresponding element of empirical theory. Where this occurs in the course of the present work, and there is agreement, as there is in the case of the Lorentz equations, the task of this presentation is complete. No purpose would be served by duplicating material that is already available in full detail. Okay, I think we're going to stop it right there. This next paragraph is a little bit long, and that's a key paragraph there just before, how he's saying that the legacy scientists generally work from physical theories have been constructed by building up from empirical foundations, whereas the reciprocal system works backward from that. The reciprocal system starts with a set of general postulates and works toward the details, whereas the other starts with the empirical and they work toward the general. Okay, we'll stop it there. Have a great day. Thanks for tuning in. We'll see you tomorrow.